Hey guys, this is Mr. Grice for Algebra Unit 7.5 Notes, Day 2. Today we're continuing our discussion on factoring quadratic trinomials. Our learning target today is to be able to factor quadratic trinomials that have a GCF. So, we talked about yesterday that when you factor a quadratic trinomial, the first thing you always want to check to see is there a GCF. Okay, after you do that, you find the factors of a times c that add up to b, if possible, split the middle term into those two factors. And then after that, we're going to use the GCF to factor by grouping the four-term polynomial into pairs. Okay? So let's go ahead and see one of our new examples. So step one always asks, is there a GCF? So is there something that I can take out of all three terms before we get started? And the answer is yes. First, all of those numbers can be divided by 2, and all of the terms have an x, and I can take out the smallest x. So when we divide, our GCF comes out front, and write the remainder. 2x cubed divided by 2x gives us x squared, plus 20x squared divided by 2x gives us 10x, and then 48x divided by 2x gives us 24. Okay? So now that we've done that, what's left over is what we were doing yesterday. So now we're just going to do the same thing. Remember that we have our terms a, b, and c. So we want to multiply a times b, or a times c, which is 24. And then we list all the factors of 24, which is 1 and 24, 2 and 12, 3 and 8, 4 and 6. So we're looking for numbers that multiply to get to 24 and add to get to 10. And we get the 10 from our b term. So what set of numbers is it? Hopefully you're telling me 4 times 6, because that works in both scenarios. And remember, this is the most important part, okay? Because we have to be able to split that middle term, okay? So this 2x comes down. Don't forget about the 2x. And what we're left with is the x squared plus 4x plus 6x plus 24. And now we're going to draw the line down the middle and split it up into the blue, or into the gray, and the blue. So what's the GCF of the gray? It's an x, x, and when we divide that out, we get x plus 2 is our remainder. Or, I'm sorry, x plus 4. Mr. Grice needs to wake up a little bit. Okay? And in the back, our GCF is a 6, and it's a positive 6. And we're left with x plus, and 24 divided by 6 is 4. Okay? And remember, we still have the 2x. Don't forget about the 2x, okay? Because the 2x is part of our answer, and then we have our two binomials. Our check right there is the x plus 4, shows us that we did the problem right. And then we have the x and the x plus 6. So we get x plus 6, x plus 4, and the 2x, okay? So the only thing that's new from yesterday is that we're starting with the 2x. We have to factor out something before we get started, Okay? All right, so it says factor each polynomial if possible and to show all your work. So number one, the first step is to check to see if there's a GCF, and there is. We can divide everything by 2. So the 2 comes out front, and then we're left with m squared plus 5m plus 4. Now in our example before, we kind of wrote that our GCF each time. What I'm going to do this time is I'm going to draw an arrow all the way to the bottom and put it in my answer. That way I don't forget about it, because I tend to forget things every now and then. Okay, so I want to do a times b, which gives us 4. Hopefully writing the factors of 4 won't take us too long. 1 times 4 and 2 times 2. So I want the factors that multiply to get to 4, but add up to get me 5. Which set of numbers is that? Hopefully you're saying 1 and 4, because 1 times 4 is 4, and 1 plus 4 is 5. So we're going to split the middle term, the m squared plus 1m plus 4m plus 4. And let's make that actually look like a 4. Okay. So we're going to split it into our front and our back. So the GCF of the blue is an m. The m comes out front, and we're left with m plus 1. Now the GCF of the pink is a 4, and that's a positive 4. And then when you divide that out, we get m plus 1. So when we write our answer, m plus 1, that's our check. And then our remainder, our 2 GCFs come together, and we get m plus 4. Remember, those come together to give us that, and those come together to give us that. All those arrows might be a little confusing. Okay, so our final answer is 2m plus 1 times m plus 4. And remember, it's the same thing if you have 2m plus 4, m plus 1. Those are the same. Okay. All right, number 2. So remember, the first thing we always want to do is check to see if there's a GCF. Okay, and in this case, we can pull out an n. So the n comes out front, and we're left with n squared plus 9n plus 8. I'm going to bring the n all the way down to the bottom, so I remember to put that in my final answer. Okay. Now, as a review from yesterday, let's see if you guys can do the rest of this on your own. Go ahead and pause the video, and good luck. So, I split the middle term, and now for this one, I'm going to do the box method. Okay. So, when we're doing the box method, we want to look at from left to right, what's the GCF? And from there, we can pull out an n. Okay? And now we're going to look at the GCF of the bottom, left to right. And the GCF of the bottom is a positive 8. All right, now let's go top to bottom. What's the GCF of the left? And the GCF of the left is just an n. After we do that, we're going to do the GCF of the right 2 boxes. And you might be like, well, Mr. Grice, there's not really a GCF of 1 and 8. Well, remember what we said, if there's no GCF, you can always take out a 1. And now that leaves us with our two binomials, the n plus 1, n plus 8. And you would have gotten the same thing if you guys would have done distribution or splitting the middle term over here by drawing the line down the middle. Okay? It's whichever way works best for you. All right, let's flip it over. Let's go ahead and get the GCF. What is it? Well, all of the terms have a y, so we can take a y out. But then we can also take out a 3. So my GCF comes out front. And now we divide everything. 3y cubed divided by 3y gives us y squared. Negative 15y squared divided by 3y gives us negative 5. And then 18y divided by 3y gives us 6y. I'm going to drop that 3y all the way to the bottom so it's in my answer. And now let's go ahead and figure this out. So I want numbers that multiply to get to 6. 1 and 6, 2 and 3. So which set of numbers multiply to get to 6 but add up to get to negative 5? So we have to be careful here because you might be like, well, 1 and negative 6. That works here, but 1 and negative 6 don't work at the top, and it has to work for both. Okay? So another way to do that, what about 2 and 3? Well, 2 times 3 works here, but 2 plus 3 doesn't work there. What happens if we change them both to negatives? Does that work? Does it work for both scenarios? You bet it does. Okay, so let's go ahead and split the middle term to y squared minus 2y minus 3y plus 6. Okay, so we have the green section and the pink section. I like mixing my colors up every once in a while. So the GCF of the front, the green, is a y. The y comes out front, and we're left with y minus 2. Now, in the back, what's the GCF in the pink? Well, remember, our leading coefficient is negative. So if our leading coefficient is negative, our GCF is negative. So we factor out a negative 3, and positive 6 divided by negative 3 is negative 2. And if you look, our check right here, we did it right, okay? So then we're left with a y minus 2 and y minus 3. You guys starting to get a hang of it now? All right, number 4, we're going to do the box method, okay? So let's go ahead and factor out the GCF. All of our terms have an x, and we can also take out a 2. So the GCF comes out front, and our remainder is x squared plus x minus 12. Just so I don't forget about my 2x, I'm going to take that directly down into my answer. And now we're looking for the numbers that multiply to get to 12. So the factors of 12 are 1 and 12, 2 and 6, 3 and 4. So out of those numbers, which ones multiply to get to negative 12, but add up to get to 1? What do you think? The only way to get 1 is by using a 3 and a 4. But which one is negative? Since when we're adding, we need a positive 1, that means our 3 has to be negative. Okay? So when we split that middle term, we would have x squared minus 3x plus 4x minus 12. If you guys want to continue doing splitting the middle term, go ahead. I'm going to come over here and do the box method. And I'm just going to write my terms one box at a time. The x squared minus 3x plus 4x minus 12. Okay? So on the left side, what's our GCF? You should get x. Okay, but now the GCF of the right. Well, my leading coefficient is negative, so that means my GCF is negative. And that ends up being a negative 3. Okay, what's the GCF of the top? The only thing we can take out is an x. And then now the GCF of the bottom, that's a positive 4. Which means that our two binomials are x plus 4 and x minus 3. All right, I think you guys are good to try one of these out all on your own. Why don't you try number 5 and see how you do. Make sure to pause the video. Okay, and there you go. Your GCF was a y, and then your two factors that multiply to 4 and add to negative 5 are negative 1 and negative 4. All right, let's move on to number 7. Once again, I want you guys to do this one on your own. This time, I'm going to do the box method to show my answer. So go ahead and pause the video, and good luck. Okay, and there you go. First GCF was a 3. You're left with n squared minus 5n minus 6. By splitting the middle term, we get 1 and negative 6. And then using the box method, I got 3 times n plus 1 times n minus 6. And remember, you can have those two binomials switched. You can flip, oops, you can flip those around to the other way. It doesn't have to be in that order. Okay? All right. 8. So is there a GCF that we can take out of all three of them? Nope, so there's no GCF. So let's go ahead. We're looking for numbers that multiply to get to 4. So 1 and 4, 2 and 2. So out of those, which ones multiply to get to a negative 4, but add up to get to negative 7? Can you think of any combinations like that? Well, there's no way you can get negative 4, but no matter what combination you try, it doesn't work out. So this one can't be factored, okay? You need to show your work, though, that you tried, okay? And this is our work showing that we tried to factor it, okay? Let's do one more. Number 9. So is there a GCF that we can take out first? Okay, there's no GCF. So go ahead and multiply those. We got 6. The factors of 6 are 1 and 6, 2 and 3. So we want numbers that multiply to get to negative 6 and add to get to negative 7. Well, I know the only way to get to negative 7 is negative 1 and negative 6. But when we come up to the top, that gives us a positive 6. Okay, so you remember, you gotta show your work when it can't be factored. Okay? Now, your homework for today is the 7.5. Is it practice B? Yep, 7.5 practice B. If you have any questions or you need more assistance, please come see Ms. Carranza or myself. We would love to help you out. Otherwise, this is Mr. Grice signing off. Thanks for watching.